Well, students, in yesterday class I was given homework to write IUPAC name of acrolein and acetyl oxide. So this is acrolein, CH2 double bond CHCHO. Well, you have to number the carbon from the end. Which end you have to number? From the right end, because we have functional group and a double bond. So preference goes to the functional group, that's CHO 1, 2, 3. So IUPAC name of this compound is prop, then 2ENR, 2ENR. So totally we have 3 carbons, so it's a propane is replaced by, here it's a propene because of double bond, prop 2En. So En means double bond is on the second carbon, then R. R means it implies it is on the first carbon itself. Well, to name this compound, first you have to expand it. That means you have to write 2CH3 group like this. Then you have to number. From which end you have to number? From right or left? It must be from right side because we have the ketonic group closer to the right end compared to the left end. So it is 1, 2, 3, 4, 5. We have substituent on the fourth carbon. So it is a 4-methyl. On the fourth carbon we have methyl group. 4-methyl. Number of carbon atom are 5 in the long chain, so it is pent. Then on the third carbon we have double bond, so it is a pent, 3En. And afterwards on the second carbon we have ONE. So you can write 2ONE or simple ONE. So this is IUPAC name of acetyl oxide. 4-methyl, pent 3En, 2ONE. And so yesterday I got confused about this one. I thought it's aromatic. It's not aromatic, non-aromatic. And for non-aromatic, that's when we don't have benzene ring, then there should be no, it is para, meta or ortho. So you have to number in the Latin symbol, it's alpha carbon, beta carbon, alpha, beta, gamma, delta, and so on. So common name of this one is, its common name is, it's beta methyl. Beta methyl, it's non. Alpha means after functional group, the next carbon is alpha. Then beta, gamma, delta, and so on. So it is, its common name is beta methyl hexanon. Then you are studied about preparation of aldehydes. 2 methods were studied. One is from nitrile and another is by Itard reaction. So nitrile is prepared by Stephen's reduction. Remember, the reducing agent used in Stephen's reduction, it is SnCl2 or stannous chloride, and HCl is the reducing agent. So aldehyde can be easily prepared by that method. First, imine is formed. We know imine means NH. Nitrogen is basic, so it immediately interacts with the HCl to form imine hydrochloride, which on hydrolysis gives aldehyde. So cyanides or nitriles can also be converted into aldehyde by using Dibal H as reducing agent. It's a diisobutyl aluminum hydride. By using that reagent, the cyanide or nitrile can also be converted into aldehyde. Well, by using Dibal H, the double bond present in the long chain do not get reduced to single bond. So, in the reaction, if you want to retain the double bond, then you must use the Dibal H to get the aldehyde from cyanide or nitrile. Then it is by Itard reaction. So you can convert toluene into benzaldehyde just by heating toluene with chromine chloride, oxidizing agent CrO2Cl2, chromine chloride, in carbon disulfide or carbon tetrachloride. And afterwards, we have one more method to prepare aldehyde. After that, we have few more methods there that is not there. Already were studied in the UC first year, but I want to revive that one. Now we have one more important method to prepare aldehyde, that's called Rosenman reduction. Well, in Rosenman reduction, acid chloride is not HCl, organic acid chloride. We know the formula for organic acid, RCOOH is the organic acid. Organic acid chloride is RCOCl. So RCOCl can be converted into RCHO by passing hydrogen gas in presence of palladium catalyst supported over barium sulfate. So this is one of the best method used to prepare aldehyde. So let us discuss about it is from acid chloride, preparation of aldehyde from acid chloride. So preparation of aldehyde, from third one is from acid chloride. From acid chloride. That is nothing but RCOCl. RCOCl by Rosenman reduction. By Rosenman reduction. So acid chloride RCOCl, remember its Rosenman reduction is converted to aldehyde by passing hydrogen gas in presence of palladium supported over a catalyst, supported over barium sulfate. Aldehyde are prepared by reduction of acid chloride by passing hydrogen in presence of palladium. PD means palladium, it's the symbol for palladium, supported over BaSO4, barium sulfate, over BaSO4. So RCOCl, RC double bond OCl, acid chloride, plus H2. So what's the catalyst? Palladium, PD, supported over BaSO4. What's the product? RCHO and HCl. So it's aldehyde. Examples. Number 1, CH3COCl. So what is CH3COCl? Acetyl chloride. Plus H2 gas in presence of palladium supported over barium sulfate, PD bar SOBaSO4. What's the product? CH3CHO and HC. CH3CHO, we know ethanol. Ethanol or acetaldehyde. Second one, benzoyl chloride, C6H5COCl. That is benzoyl. We know benzoic acid. Benzoyl. The acid is benzoic acid. So its chloride is benzoyl chloride. Benzoyl chloride plus H2 gas in presence of palladium supported over barium sulfate. The product is benzaldehyde and one more is HCl. Is benzaldehyde. In resentment reduction, you are using acid chloride, example acetyl chloride or benzoyl chloride. So what are the other reagent? Hydrogen gas, catalyst is palladium and it is supported over barium sulfate. So remember, resentment means it is acid chloride and H2. Catalyst palladium. Well, afterwards we have one more method. That method is called Gattermann-Koch reaction. By Gattermann-Koch reaction. Here also you are getting benzaldehyde. So it is the special method for benzaldehyde. You are not getting other aldehydes by this method. So in this method, benzene is treated with carbon monoxide and HCl in presence of aluminum chloride and traces of copper. The product is benzaldehyde. Benzaldehyde is prepared. Benzaldehyde is prepared by treating benzene with CO and HCl. It must be capital, carbon monoxide and HCl in presence of AlCl3. Sometimes you are using with traces of copper. Well, without copper also the product is obtained. So this reaction is called Gattermann-Koch reaction. We have benzene, then it's carbon monoxide and HCl. In presence of AlCl3 bar little copper. The product is benzaldehyde. This is called Gattermann-Koch reaction. CH2. So all these reactions are important. One is from cyanide, it is reduction of cyanide by using SnCl2 and HCl. That's called Stephen's reduction. Second, it is by using toluene. That reaction is called Itard reaction. Then Russellman reduction and Gattermann-Koch reaction. So remember all these names and what type of product is obtained, what are the reagent required to get the aldehydes by this reaction. We have few more methods. For example, we are studied in PUC first year. We can prepare aldehyde from alkenes. The process is called ozonolysis. That reaction is reductive ozonolysis of aldehyde. Reductive ozonolysis of alkene gives the aldehyde. Reductive ozonolysis means you are using Zn as a reagent. So Zn with the H2O2 after ozonide is formed, it is treated with zinc dust and water to get the aldehyde. Suppose if you are not using zinc dust, then aldehyde formed in the reaction is further oxidized to carboxylic acid. So this reaction is called reductive ozonolysis. Even from alkynes, it is possible to get the aldehyde just by hydration. So simple passing alkynes into water won't get the aldehyde. Some condition is needed, say in presence of mercuric sulfate or some mercuric salt and acid like H2SO4. Addition of water into the triple bond takes place. You may get the aldehyde or ketone, it depends on the structure of alkyne. Whether alkyne is present, its triple bond is present on the terminal carbon or at the center, or maybe not on the terminal carbon, the product is ketone. Well, so other methods. Remember, all these methods are important. Remaining methods are, it is not there for the board examination, but you have to prepare it from the point of CET or NEET or JEE. Other methods. So, number 1, from alkenes or by ozonolysis or by, it's better to write reductive ozonolysis. Reductive ozonolysis or alkene. So ozonolysis is nothing but reaction of alkene with the ozone. So it's R CH double bond CH R dash plus ozone O3. Well, here double bond get converted into ozonide. This is R CH, then we have O CH, then oxygen and R dash. Afterwards, the hydrolysis, that is reaction to water. So reductive means in presence of Zn. The breaking of this bond takes place. So we have RCHO, RSCHO, and then we have H2O2. RCHO plus RSCHO. Where R may be any group like CH3 or C2H4, similarly R dash may be any group. So it is called reductive ozonolysis of alkene. First, formation of ozonide, then breaking of ozonide into aldehyde by adding water in presence of Zn. Second one, hydrolysis, that is hydration of by hydration of alkyne. By hydration of alkyne. As I told, remember, you are getting aldehyde from the alkyne when the triple bond is present on the terminal carbon. That is, it is possible to get aldehyde when you are using ethine. It is ethine, E-T-H-Y-N-E. So it is CH, triple bond CH, ethine plus H2O. What are the conditions? In presence of HgSO4 and H2SO4, dilute H2SO4. So product is CH3CHO. So product is acetaldehyde or ethanol. Then we can also prepare aldehyde from benzaldehyde. From it's benzyl chloride. From benzyl chloride. So what is this benzyl chloride? Benzyl chloride means it's a fluoro-derivative of toluene. The two hydrogen atoms of CH3 are replaced by chlorine. That's called benzyl chloride. And you are getting that benzyl chloride when the toluene is treated with chlorine in presence of sunlight. So side chain substitution takes place or side chain chlorination takes place. At first you are getting benzyl chloride, one hydrogen is replaced by chlorine. Next another hydrogen is replaced by chlorine, that's called benzyl chloride. There is one more possibility, all hydrogen may be replaced by chlorine, but we want benzyl chloride. So here benzyl chloride itself is obtained by treating toluene with chlorine in presence of sunlight. So the second product in the reaction is CHCl. What's the first product? First product is CH2Cl. Second product is benzyl chloride. So benzyl chloride on treating with NaOH, solution of NaOH, you are getting benzaldehyde. Benzaldehyde is the product. One more is NaCl. So after this, now we have to discuss on the preparation of ketones. So after the preparation of aldehydes, it is preparation of ketones. Preparation of ketones. Well, in the preparation of ketones, first one is from acid chloride or acyl chloride. We know formula for acyl chloride is also called acid chloride, or example is acetyl chloride. It is CrCoCl. So RCOCl can be converted into ketone by using dialkyl cadmium. So when dialkyl cadmium is treated with acetyl chloride or other acid chlorides, ketone is formed, and that dialkyl cadmium itself is obtained by treating cadmium chloride with Grignard reagent. Okay, so number one, from acid chloride or acetyl chloride example here, ketones are prepared. Ketones are prepared by treating acid chloride with dialkyl cadmium. So here dialkyl cadmium is obtained. Dialkyl cadmium is obtained by treating cadmium chloride CdCl2 with Grignard reagent. We know it's a RNGX. So first I am writing how that dialkyl cadmium is obtained from Grignard reagent. We know RMGX is the Grignard reagent treated with, I am writing RDAS because you have to use the acid chloride, for that I am writing RCOCl. So RDAS MgX plus this cadmium, RDAS MgX plus cadmium, it's a CdCl2. The product is cadmium chloride. The product is R2, R-2CD and Mg, 2Mg, HCl. So now acid chloride, RC double bond OC, we know it is called acid chloride, is treated with dialkyl cadmium R-2CD. The product is RCOR dash, the balance equation, write 2 times, and CdCl2. So example is CH3 COCl. We know it is called acetyl chloride, plus it is CH3 twice CD dimethyl cadmium. The product is CH3 COCH3 COCH3 and CdCl2. Well, the next method is this by Friedel-Crafts reaction. Second one is by Friedel-Crafts reaction. We know Friedel-Crafts reaction is nothing but reaction now. Hydrocarbon like benzene with acid chloride or alkyl chloride in presence of N-nitrous aluminum chloride. So to get the ketone, you have to use acid chloride. Well, example I am writing directly. It's acetophenone is prepared by treating benzene with acetyl chloride in presence of AlCl3, N-nitrous AlCl3. So equation is benzene plus acetyl chloride. Equation is very simple. Benzene ring and acetyl chloride in presence of AlCl3. The product is acetophenone CO, CH3 and H. So this is the Friedel-Crafts reaction. You can also prepare ketones from cyanides or from nitrites. So this is acetophenone, and we know the IUPAC name of acetophenone. Acetophenone. And third method from nitrite. So nitrile we know RC triple bond N. It's nitrile. When treated with Grignard reagent, it's R-MgX. Grignard reagent. The product is RC R- double bond N. Then we have MgX. So this is the middle product, addition product. This on treating with water, this on hydrolysis, you are getting RCR-, then double bond O. It's called ketone. So this one is ketone plus we have MgX and H2. So this is our C double bond O R-. Well,